Hello everyone. Welcome to the first CIVE391 Soils Lab experiment. The topic of this experiment will be liquid and plastic limits of soil. This experiment consists of 3 parts. Part 1, the liquid limit test. Part 2, the plastic limit test. And lastly, moisture content determination. For each of these parts, the lab manual, Section 1, Soils Lab, is a required resource. For the liquid limit test portion of this experiment, several different pieces of equipment are required. These include the following: a liquid limit device, plastic squeeze bottle, mixing bowl and spatula, and a grooving tool. Now we may begin the procedure for the liquid limit test. First, before using the liquid limit device, check that the height of fall of the device is 10 millimeters. Adjust the height of fall to exactly 10 millimeters using the block end of the grooving tool if necessary. Next, place approximately 250 grams of soil sample passing through a number 40 sieve in the mixing bowl. Add a small amount of distilled water and thoroughly mix the sample. Continue to add more water in small amounts and thoroughly mix to a uniform color and consistency. Make sure there are no lumps. Poor mixing is a major source of error in this experiment. Add more water to the original sample and continue mixing until it is estimated that it will take 30 to 35 blows to produce a standard groove closure of 13 millimeters. This is steps 5 to 8 in the lab manual. Now place a portion of the mixture onto the cup. Using the spatula, smooth the surface of the soil in the cup such that the maximum depth of the soil is approximately the depth of the grooving tool, about 8 millimeters, as shown in Figure 2A of your manual. Using the grooving tool, cut a straight, clean groove along the center line of the soil pat in the cup. The depth of the soil in the deepest parts of the patch should be even with the top of the grooving tool. The soil depth should be trimmed with the shoulders of the tool at the deepest part. This is shown in Figure 3B and C in your manual. Turn the crank of the liquid limit device at the approximate rate of 2 revolutions per second. The soil from the 2 sides of the cup will begin to flow towards the center. Count the number of blows N for the groove in the soil to close through a distance of 13 millimeters as shown in Figure 3D in your manual. Record your results in the datasheet provided. Collect a moisture sample, approximately 40 grams, and determine its water content. Make sure that the sample being taken is from the closed part of the groove. Remove the remainder of the soil from the brass cup and return it to the mixing bowl dish. Wash and dry the brass cup. Repeat the sequence of steps to get at least 2 additional tests. One of the tests shall be for a closure requiring 15 to 20 blows, one for a closure between 22 and 25 blows, and one for a closure between 30 and 35 blows. If the blow counts are in this range, you should have a reasonable spread of points around and close to the critical value for the most accurate determination of liquid limit. Next, we will move on to part 2 of this experiment, the plastic limit test. Once again, several pieces of equipment are required for this part. They are as follows: a plastic limit plate, a squeeze bottle, mixing bowl and spatula, and a 3 mm diameter steel rod. Next is the actual procedure for the plastic limit test. To begin, place 20 to 30 grams of soil in a small mixing container. Add a small amount of water and mix thoroughly. Now break the soil on the plastic limit plate into smaller samples approximately the size of a peanut. You should now roll one of these smaller samples with your fingers on the plastic limit plate. Apply sufficient pressure to form a uniform diameter thread using approximately 80 to 90 strokes per minute. Note that going forward and backwards once is equal to 1 stroke. This is shown in Figure 5 in the manual. Afterwards, break the thread into several pieces, reform into a ball, and re-roll as described above. Continue rolling and alternately re-balling until the thread crumbles under the rolling pressure and the soil can no longer be rolled into a thread. If the thread crumbles at a diameter greater than 3 mm, it is satisfactory to define the plastic limit if the previous thread was rolled to 3 mm. Thread failure may be defined as falling apart, where the outer tubular layer splits from the end inward, or barrel-shaped, where solid pieces 6 to 8 mm long are formed. Do not produce a fracture. Allow the thread to reach a 3 mm diameter by reducing the rate of rolling and/or your hand pressure. Determine the water content of the crumbled thread as outlined in the appendix in your manual and as demonstrated later in this video. Repeat the above procedure to obtain duplicate data from 3 separate tests. Finally, this part of the experiment is on moisture content determination. Once again, certain pieces of equipment are needed for this section. They are as follows: moisture tins, an analytical balance, and a drying oven with temperature control. What follows next is the procedure for moisture content determination. First, label and weigh the moisture tins to the nearest hundredth of a gram. Make sure the balance is zeroed and that the same balance is used each time. Next, place a representative sample of wet soil in the moisture tin, approximately 40 grams, and determine the weight of the wet sample and tin. Place the moisture tin in the specified drying oven at 110 degrees Celsius. Allow the sample to dry in the oven until the sample has reached a constant mass. This process usually takes about 12 to 18 hours. Afterwards, determine the mass of the moisture tin and the now dry sample. Make sure the same balance is used as for the first step. Finally, calculate the moisture content using equation 4.0 in your lab manual. That concludes Experiment 1, Liquid and Plastic Limits of Soil. Next time, we will conduct Experiment number 2, Specific Gravity of Soil Solids.